Okay, now let us welcome Dr. Tardo to share his knowledge on visual data visualization to all of us. And I believe he delivered a certain talk a couple of semesters ago. I believe there are some new information we can learn from him. Thank you.
So I'm going to start somewhat ironically with what you should not do. Okay, these are bad examples. These are examples of very bad visualizations. Okay, so this one from a Journal of Pragmatics paper, you know, if you look at this graph, I don't know, I don't even understand what they're doing. Okay, it's a mess. It's a complete bloody mess. Uh, I mean, do you understand it? Okay. So what are the problems? So first of all, the shading choices, the colors, the patterns and whatever are just awful. You know, it's like, the yellow, the purple, the blue, the pink, it's all over the place. There is no coherent color palette. Um, you know, why is this horizontal as opposed to being vertical? I mean, it's just like the whole thing is baffling. Not to mention, if I want to know how many okays did Emily say, can you figure it out from this picture? The okays would be the yellow.
I mean, I want to read it like three different ways. Like, I don't know if they did 33 or if I have to like subtract the O's and the yeahs, that kind of thing.
Something over
That's what
20.
I'm saying. Okay, that is
Yeah.
it's basically unfathomable from this chart. Okay, the only thing that is clear is if you ignore completely all the different shadings, Emily uses way more discourse markers than Chi-Wei. All right, and
Mhm.
that's the only bit of information that's clear from this graph. Okay, so the point is it's very bad from a visual standpoint.
Mhm.
Okay, because the color, the patterns, the organization of the graph is absolutely garbage, and so you can't understand what's going on. Okay, they should have done something completely different to present this information. So here's another example. On the right, this one here, you see my cursor when I move it?
Yeah.
Yeah. Okay, so this graph here is the graph as it was published by in the Tagliamont and Dennis article. This is a very good article. I really recommend it. Um, but what's wrong with it is that the data is organized counterintuitively. So we're going from the 19, 20-year-olds to the 17, 18-year-olds to the 15, 16-year-olds, right? So this makes it very difficult to sort of wrap your head around it. So, for example, if I say, um, who uses more LOL in 2004, right? Who used more LOL than, okay. So from this graph, you have to say, okay, wait a minute, let me try and figure this out. Okay. Now look at the version on the left that I made in 12 seconds using a spreadsheet. Okay. This is just the data for LOL, but I've reordered them in the intuitive way, which is youngest first, older uh, to the right? So there is the natural growth of age. And from this, you can see immediately, without having to even think about it, that as you are younger, you use more LOLs. You used in 20 years ago more LOLs, right? So that's the difference between an intuitive graph where the information is organized as you expect it and a counterintuitive graph in which the information is organized against expectations. And that makes it so much harder to understand what is going on. Okay? So this gives us a first, I don't know, rule that we can follow. Present the data as you are expected to do, right? So in other words, don't baffle expectations. Don't go against the expectations, right? So, we just saw time flows from left to right. Okay. Now, of course, this is a cultural thing, and in other cultures is different. La la la, right? Of course, but we're talking about the Anglo-Saxon world. Okay. Now, the week begins on Monday. Okay, not on Sunday, not on Wednesday. Okay, so if you are describing a week, you have Monday, Tuesday, etc., and then Saturday, Sunday is the weekend. Okay, and again, this is culturally specified. In other countries, in other cultures, is different. Okay, now look at this. This is actually my electric bill from a few years ago. What do you spot immediately that makes it confusing?
It doesn't start on January.
Correct. It starts in March. Okay. Now I'm sure that they think it's clever because this is the March data, right? But in fact, it's confusing as all hell. Okay, because if you look at this, you say, okay, when is my period of greatest usage? Well, it's December, January, February, March, right? But I have to think about it in order to find the information. Whereas if I had found January at the beginning, I would have looked at the beginning, right? Because that's where I expect January to be, because the year starts in January. Okay. So again, my point is if you meet the expectations of the viewer, of the reader, it's going to be easier to understand and therefore better. Okay, because ultimately you want your reader to understand what you're doing. All right, so here's an example of using the wrong kind of chart. Okay, so this is a pie chart. Okay, and this is me having reformatted the data properly. Okay, now what's wrong with the pie chart? Anyone?
A pie implies that there is a totality of which these are
There you go.
segments.
Good job.
So this looks like Williamson is 30% of the data, but it's not. 30 is just the actual number of whatever it is that Williamson did. I have no idea what it is, but it's not 30% of the total. Okay? So the pie indicates that this is 100% of the product, but in fact it's not, it's the total of the product. Okay? So it's very confusing. Also, there is no reason why Ramat Shah should be next to Williamson. Okay, as you can see, it's organized in a clockwise direction from the greater level of productivity to the lowest level of productivity. Highest number, lowest number. Okay? But of course, then there is no reason why the smallest should be next to the biggest. Okay? Now look at the chart that I reformatted on the right. That tells you immediately, well, there you go. This is it's organized in order of greatest number to the left, smallest number to the right, whatever these people or these places are, these companies are, we don't know, but it doesn't matter. The point is that the bar chart on the left, on the right, is enormously clearer than the one on the left because there is no thinking, oh, these are percentages, right? That is this idea that perhaps their percentages is an artifact of presenting it as a pie chart. Okay? So, and the circularity of it, again, is an artifact of presenting it in a circle when there is no circularity in the data at all. Okay? So again, this is a very bad visualization. It should have been done the way I did it on the right. Okay? All right. So these were just examples of how you can screw it up and make instead of being useful, the visualization becomes deleterious. It goes against your goals, right? So the biggest point that we need to make is that there are almost an infinite number of visualizations. Okay, that's one thing that I learned from looking at this stuff, is that you always discover new types of graphs and new things and other ways of presenting information, right? So I found this little chart from Syracuse University, which I stole immediately. These are a bunch of types of charts which you can look at. Most of which you should be sort of familiar with. Maybe heat maps you may not be very familiar, but if you do eye tracking, you'd be familiar with them. Word clouds now everybody is familiar with, but they used to be very, very rare. So you've got these things. And then there's other things like violin plots, Meko charts, tornado charts. The tornado chart I like because it really kind of has the shape of a tornado, right? It looks like a funnel, because it goes from the biggest number on top to the smallest one, right? And it's a nice way to visualize the overall impact of the numbers here, right? The cost of college in this particular case. Okay, so that's just to give you an idea of the fact that we're only going to talk about a few examples. We're not going to cover all of them. Okay, so the side note here is you need to spend some time getting familiar with the type of visualizations that people use in your field. Okay, so you will discover that depending on what you're doing, people prefer certain kinds of charts. Okay, so when you're doing your literature review, one of the things you need to do is keep your eyes open and say, what kind of images do people use? Okay, what kind of graphs do they use? Okay, now on a deeper level, the biggest point that I'm going to make today is this. Use an image to make a point, not just to display data. If you're using an image just to say, here's what my data looks like, don't. Save yourself the trouble. Don't put the image. You're wasting everybody's time, yours and the reader. But your image should have a point. If you have a point and you make it clearly, then the image, as they say, is worth 1,000 words. So here I have an image from one of my papers, not because it's a particularly good image or whatever, but it's a graph that makes a very, very clear point. Okay. Here, this was an eye tracking study that I did with some colleagues, and we were looking at like memes on Twitter, right? And the idea was when we present this image to the subjects of the study, the participants, do they look first at the text or do they look first at the image, right? Because in a meme you've got the text, there's a caption, etc., right? But then in some cases they looked outside of the image and of the text, right? So they looked at something else. So we wanted to know, when does this happen? And so on the bottom axis, you have the time in milliseconds, right? So from 0 to 5 seconds, 10 seconds, 15 seconds. And you can see immediately that the vast majority of fixations looking outside of the image and the text take place in the first 100, 200 milliseconds. So right away, right at the beginning. Okay, so that's why this chart is a good chart, because it makes a point. Okay, the point is most of the fixations outside of the image take place right at the beginning of the processing. Okay, that's it. It's a very simple, very straightforward point, but it's done in a very clear visual manner. Okay, so we're making a point, we're not just displaying data. And again, you need to be very careful because when you produce an image, it's easy to try and jam stuff into it. Remember the first picture at the beginning where they tried to put like 20 bits of information in one image, and of course it fails. This image that you see repeated there in the corner has 2 bits of information, okay? The frequency, the number of fixations, and the length of time in the watching, that the person is looking at the tweet, right? So there are only 2 variables, time and frequency, okay? And that's it. So it's the simplest chart you can imagine, right? 2 things. Now, other kinds of charts are more sophisticated, more advanced, right? So for example, box plots, okay? Now, keep in mind all the text here I have added to explain what it is. Okay, so normally, actually I think I have, yeah. So this is what a box plot would look like, the output that you would get and the image that you would put, right? So, but here I put to explain what they mean, these things, right? So my point here is that there's way more information, okay? It's telling you where the median here, what's the lowest value, the highest value, the quartiles. That's a lot of information, okay? But again, it's very helpful, right? Because here I'm comparing, these are, by the way, it's a data set that comes with R, so that's why you have murder and rape. These were crimes committed in the 1970s in Illinois, I think, or something like that. It's just a data set that comes for free, right? So looking at this box plot here, what's more frequent, murder or rape?
Rape
Rape. Is the difference significant? Yes.
looks like there's a
How do
significant
we know?
difference. A sharp contrast. It's one is much higher, I guess.
Sorry?
One looks much higher, the numbers.
Right, but there's a very specific thing. The box here and the box here do not overlap, right? So that tells you that it's a significant difference. Okay, again, intuitively, we're not talking like number, but if you do the math, you'll find that in fact the difference is significant. Okay, so my point here is that with a box plot, it's a way more sophisticated graph, but it still allows you to intuitively grasp the fact that rape is much more frequent than murder in Illinois in the 1970s. Okay, I mean, again, this is not, we're not looking at the data here. Okay, all right. Now, another kind of graph that's ideal for things that occur in time. Okay, so in the previous graph, we're looking at the overall number of murders and whatever, right? So here, instead, we're looking at things over time. This is a graph that I made a long time ago to show how our graduate program was growing between 2015, when we started the graduate program, and 2021, 2022. Okay? And as you can see, the undergraduate stays more or less the same. We produced about 500 semester credit hours per semester, or per year, I think. Whereas, as you can see, the graduate program grows very, very fast and then settles at about 2,000 semester credit hours a year, right? So, but there's a dip in 2018. Okay. So that this is, again, if you're looking at things that take place over time, okay? So this is over 7 years of data, right? So that tells you something historically, right? And again, a line graph like this makes sense if you have stuff that's spread over time. Okay? It wouldn't work if you were comparing absolute quantities. Okay? So you need to pick the graph that matches what you're trying to describe. Now, this is, again, slightly more advanced, because what we're doing is we're plotting, this is a dot plot, a scatter plot, right? So we're plotting one variable against another, okay? So let's use the example of the beer quadrant there. So the idea is that you have authoritarian versus libertarian in the vertical axis, and left wing versus right wing on the horizontal axis, right? So, for example, IPAs is authoritarian left, right? Because it's hipsters that drink IPA. Lone Star, of course, is the beer, the state beer of Texas, so it's right-wing authoritarian, okay? Bud Light is central. It's the neutral beer, right? Miller High Life, where is it? Pabst Blue Ribbon is all the way to libertarian. It's the beer of the working class, right? Anyway, so again, you have two axes of value, and then you put stuff, according to both of them. So here you have a scatter plot of the size of the population on the vertical axis and the number of arrests for assault in the United States. Okay? So as you can see, there it's kind of all over the place. But if you put in a regression line, you can see that there is some degree of correlation that says that the bigger the city, the more assaults, arrests there are going to be. Okay, it's not a strong correlation, but it's a correlation. That's because the blue line is going up. Okay, if the blue line had been going down, it would be a negative correlation. Okay, again, this is intuitive. It's a Gestalt perception. You can see that the dots are not completely randomly in the graph, right? But the line helps you visualize exactly mathematically what's going on. Okay, so again, it's a bunch of information, but it's clearer if you look at the version with the line. It's more intuitive than me saying the greater the urban population, the larger the number of assault arrests. Okay, it's more intuitive, and that's the point of having visual representation. Now, if you want to, depending on what you're doing, you may put more than two variables in a scatter plot, okay? So you can use color and size of the dot to indicate other variables, okay? So for example, again, this is a data set that comes with R. That's everybody uses it for examples. It's about irises, the flowers, right? And this, so it's the species and the length of the leaf, I think. So with the color you indicate which species it is, and then the length and the width are the vertical and horizontal axis, themselves, right? So here you see immediately that all the red dots are in the wider width, and most of the blue dots are in the longer length, right? So that tells you that then the species of irises tend to pattern this way, right? So the use of the color helps clarify the relationships between these data. Okay, and these are just two ways of doing the same graph, but using different packages in R. Now, if you look at this graph here, this is even more sophisticated, and so it loses a little bit of the intuitive impact. So what you have is that the color indicates the number of cylinders of cars, right? This is a data set of cars. MPGs is the miles per gallon, and this I don't remember. Does anybody remember what the WT stood for? Maybe weight.
That's what I'm thinking.
Anyone? No, doesn't matter. Whatever this is. So, and this is the speed at which it can it can reach, right? So the size of the circle and the color. So you can see that as you go to the larger weight, the mile per gallon drops dramatically, right? So the cheapest cars to run are here, with the 4-cylinder as opposed to 8 cylinders, right? The 8 cylinders cars are the red ones that have the worst performance. Okay, so again, the point is that you can overlap different bits of information in a scatter plot, but as you add more information, it becomes more complicated. Okay, so this I'm going to ask Dr. Hempelman to explain because I took this picture from his paper. It's called the chord diagram, and it's, I think, Spanish and English translation of the words.
Yeah,
for
those are
laughter.
the two. Yes, so half the paper in which this was published tried to explain how these graphs work. Once you get them, they're really good. So this is a circle divided into two halves. Unfortunately, it's slightly turned. So you see the division where the circle has a gap towards the top and the bottom. And each half represents roughly 400 tokens of words that refer to laughter and similar behavior. 400 on the left in Spanish, 400 on the right in English. And the chords from one side to the other. Well, I'm already wrong with where the gap's supposed to be perceived. Because I see the English ones and the Spanish ones, roughly English at the top, Spanish at the bottom. Okay, starting over. See, this is not a good graphic. Bottom 400 Spanish words for laughter, often a lot of the same token. Top one, 400 English words for laughter. And this is a translation of a book from English into Spanish. So it maps for each instance in the English book where something was referred to as laughing-like behavior, what was the Spanish word used for it? Once you get all this, if you did get it, the chords between roughly the top and the bottom nicely show that the instances of the English words laugh at the top left in red were mostly translated into the Spanish root reír, I think. And as a final example, the instances in green at the top of the English word grin were by and large translated into the Spanish root sonreír.
All right. So again, the point is this is an advanced visualization, right? You wouldn't do this in a term paper unless you have a very good reason to do that. Okay. Now, in the paper, I promise you, it makes perfect sense. Okay. And when you see these kind of diagrams, it takes a long time to study them. You have to work on it to understand them, but they can be very revealing. Okay. This is again, it's not straightforward, but that's the point. It's advanced visualization.
Can I ask a quick question?
Yeah, sure.
This looks very complicated to me because actually it's quite new to me, to be honest. May I know why? Maybe it's a very silly question, but may I know why all these Spanish words are actually just really concentrated on that specific, left, button color? I just didn't understand why it does not spread out like, the English words goes like, cover the multiple portions there. I just didn't get it.
Not sure about your question, but I think this may answer it. So in English, there was a very limited number of words. This is the
Uh-huh.
source language. It's actually one flew over the cuckoo's nest. And in
Okay.
English, we had tokens of laugh, grin, giggle, smile. That
Okay. We have only four or five.
before
Okay.
in the target language that we consciously selected. And then we looked at what were these 400 instances of these four words translated into in Spanish. And the translator made choices in Spanish that included a bunch of other words. So
Uh-huh.
in the bottom left quadrant, you see words in Spanish that are the translations of laugh, grin, giggle, smile
Mm-hmm.
that are used only once or twice or a few times. Is that what you were after?
Yeah, I can see that connection, but my question here is why it is like displayed, all these Spanish words displayed at that specific, left side. So I'm just curious about, anyway, I just don't know why this is, the specific connection from it
Well,
seems to me I focus on from right to the left in
We
this
okay,
way.
sort
so
it by frequency. So um,
so the way it works is that this is the division.
Okay?
Okay, above it's English, below it's Spanish, right? So
Yes.
in order to find how the word smile was translated, you follow the chord and you
Okay.
find that it was translated as sonreír, right?
I see. Okay.
And then grin also was
I see.
translated as sonría in Spanish.
Uh-huh.
Okay,
Uh-huh.
so
Uh-huh.
apparently in Spanish there is no difference between grinning and smiling. Okay,
Okay.
except in a few cases of grinning, it became WEC, which I have no idea what that is. We need a Spanish speaker to tell us.
Okay. Yeah. Yeah. It makes sense now.
So it's actually a very powerful visualization because
Mm-hmm.
you know otherwise it would require paragraphs and paragraphs of prose
Mm-hmm.
to convey this fact.
True. Thank
Again, advanced visualization. This is really the key here is advanced. All right. So here's another example of advanced visualization. Now, this one is not advanced in the sense that it's complicated like the core diagrams. This is very clear, right? It's a map. Okay, so yeah, but it's very difficult to produce. In order to produce this map, it took me probably a few days of work. Okay, because the data has to be exactly a certain way. It wasn't easy. Okay, so what we did here is we were looking at this is a paper that I co-authored with Dr. Miller and other colleagues. So we were looking at two satirical newspapers, the Babylon Bee and the Onion. Babylon Bee is conservative, the Onion is more progressive. So we wanted to see whether the place where they said that the article was written, so they're fake news, right? So then fake news come with a dateline, right? It says, Chicago, April 13, right? So that's the dateline, right? So they tell you where the news happened. So we wanted to see if there was a difference in the location of the news because there is this idea of the flyover country, right? The idea is that the liberal elites are on the East Coast and the West Coast, and then in the center are the conservative voters, right? That's the myth, okay? But as you can see, so the visualization is the darker colors are the greater number of news. But as you can see, there is a little bit of the flyover effect because you can see that both the East Coast and the West Coast are darker than the center, but there is no real difference between the Babylon Bee and the Onion. Okay. The other thing that I wanted to point out is that unlike the first graph that I showed you where the colors were a mess, this is done using a color palette provided by R, which is very clever because, as you can see, turned into grayscale, the readability is the same. You lose the nice colors, right? But you can turn it to grayscale and it's perfectly readable. That's what I did. I took the image, converted it to grayscale, and as you can see, nothing is lost. Okay, so that's a really useful tool, is to use these color palettes because they will stop you from doing horrors like the first chart that I showed you. Okay, so that's a very valid thing. Also, it's compliant. I forget what it's called, accessibility, for people who have vision problems, right? If you're colorblind, for example, this palette is perfectly acceptable, whereas the other one wouldn't be. All right. So summing up, and again, I'm not saying that this is everything, but some basic principles that I would like you to take as a takeaway. Use the visuals to make a point. Okay, don't just have, oh, this is what my data looks like. Stick to intuitive visual features, such as, for example, quantity. A higher bar means more than another one. Rely on conventions, like, for example, box plots, or a standard way of presenting the information, for example, the order of the months, the order of the days, etc. Homologies just means similarities, right? If there are similarities between the data and the visualization, such as, for example, the direction of time, then use that. Okay. Use the we intuitively capture gestalts, holes, so you can use that for scatter plots, etc. They express visually something that would take a long time to explain. And then again, use color meaningfully, not in a decorative way, because that's confusing and it doesn't help. Okay. And again, if you can use a color palette that is readable even in black and white, you're doing a better job. All right, and that's all. Questions?
Hi, Dr. Tato. I have one question.
Yeah.
I wonder if you use any software or website to make these visuals?
Yeah, I use R.
R?
Yeah.
Oh, thank you.
Yeah. But I mean, you can do this using Python. There's libraries for this. You can do it in Excel, although I wouldn't recommend it. You can do it, pretty much any decent statistical software will let you do most of what you saw. And again, unless you're doing something extremely specific, like the chord diagrams, right? So something like that, you would say, oh, I'm going to need to do this kind of visualization, and it's going to be part of your training for your dissertation to use that and how to make them, et cetera, right? But if you need to do a bar chart or a line graph, Excel can do it. Any decent spreadsheet or statistical software will be able to do it. If you need to do something for publication, then maybe using R or Python or those kind of tools, that are professional. You can produce charts that are unbelievable. using these tools. But there is a learning curve. Right?
Okay, I have one more question, Dr. Attardo. Well, for the advanced visualization, the code visual, and I wonder if if they use this code visual to look fancier in their publication, or they
No,
think this is the best way to
no,
present their
the
data.
chord visualization, usually I see it in political analyses, not necessarily as a circle. But I see it in political analysis where they say, so we have the voters from the 2016 election in 2022. We see that this group shifted to this group and that group shifted to that group, and so they do these chords, to indicate the flow from various groups into other groups. So that's usually where I see it used fairly frequently. Okay. Um, I don't know, and Dr. Hempelman can tell us, I don't know if in translation studies that's used, or if it was a novel idea of yours to do that.
I think it was novel. It's called Circos, CIRCOS.
But so it was your idea to use it to show translation. Yeah, that was a brilliant idea. Because and again, it's very specific to the problem that they had in that papers to show how do things get translated. So, but if you don't have to do that, then why would you use it? You see what I'm saying? That is, it just doesn't, you wouldn't use that to show the relative quantity of students who did well on the test and did poorly on the test. It just doesn't, makes no sense.
Okay, thank you.
Thank you, Sal, for such an informative session. I have a feeling like I myself usually just use these bar charts. I think those are highly related to the research questions you actually posed and your goals for that specific project, right? So it turns to me that mostly a lot of like quantitative studies, they tend to use visuals more. Am I correct? Because actually, I feel like it's enough for me to just use like bar charts, tables. I
Well,
didn't really dare trying some new, but today, I mean, I definitely learned a lot. And do you think, do you have any opinion about this? I mean, how can this, maybe the qualitative study can, be different from the quantitative studies in terms of the visual, representation?
yeah, I mean, obviously, if you're doing a qualitative study and you stay away from quantifying your data in any way, why would you use a visual representation? It just doesn't but if you're quantifying something, then it starts to make sense to visualize it, because again, the thing is that the visualization offers an intuitive way of grasping the data.
That's right.
You know, now I don't do qualitative research, but I've been reading about it from a methodological standpoint, and there's lots of people who are pushing for quantifying qualitative research. So using numerical
Numbers.
so once you start doing that, then you're back in the game with the visualization, because if you want to show somehow the relationship between the number of people that did this and number of people that did that, etc., well, now it lends itself to a bar graph, or that sort of thing. um and it's like the purpose of the visualization is to help you think through your data. That's really,
And also, it's also helpful for the learners as well, for the readers,
yes, of
because
course.
they can just capture the gist of the meaning,
Right.
right? So
Yeah.
effectively.
if the visualization is good, it really helps the
Mhm.
reader.
Yep.
And of course, if the visualization is bad, then no, not so much.
Distracting. Okay. Thank you so much.